Okay, well, in the interests of being on time and punctual, we should kick off the session. And the way it's going to run is that we're going to introduce all the papers and then watch all the videos in one block. And during that time, if you have any questions, please type them into the chat. And if they're directed towards a specific paper, please denote that. And if they're more cutting across the papers, please mark that. I will then try and keep an eye on those questions during the session. And then we can facilitate a discussion where we ask the questions to the presenters at the end and hopefully have a bit of a chat in the session itself and see what we can take out of this session that's productive for everyone. We have 5 really interesting papers. I've been quite happily reading them this morning. The first paper that we're going to see is how to assess a creativity session, presented by Lili Coustillac. And her co-authors are Bazzaro, Lobbé, and Meyer. The second paper is testing the usability of guidelines for the design of surprising products, which is quite a surprising paper to read, presented by Niccolò Becattini and his co-author Raafat. Then we have a reviewer's favorite paper for Do You See What I See? Exploring vividness of visual mental imagery in product design ideation, which certainly is not the shortest title ever, presented by Laura Hay and her co-author Hart. Then we have the relation between the characteristics of individual and collaborative concept generation by Matsumae and Hirasawa, and Hikari is here. And finally, we have an approach to the transfer of biological solutions based on the interpretation of mechanisms to technical products by Marcel Bartz and his co-authors Uttich, Wanieck, Bender, and Wartzack. So I think we have a really interesting session. There's quite a lot of synergy between these papers, actually, in terms of several of them are presenting design methods or design principles. And the work on Do You See What I See is also to do with like interpretation in this context. So I think there's quite a lot of commonality in what we can discuss in this session, and we should actually be able to get some nice insights out for the community and for the authors. So without any further ado, I would like to hand over to Marco to play the videos. If everyone could please mute themselves during this time and restrict themselves to just typing frantically questions into the chat, that would be very much appreciated.
Hello everybody, thanks for joining this presentation. My name is Lili Coustillac. I'm a second year PhD student at the Roberval Laboratory of the University of Technology of Compiègne and at the FemtoST Laboratory of the University of Technology of Belfort-Montbéliard. I'm doing my thesis at Forvia Faurecia, the world's 7th largest automotive technology company, and more precisely in the innovation laboratory of its Clean Mobility business group, specialized in sustainable mobility. The objective of the innovation laboratory is to support all clean mobility teams in reducing time to market of products and services. For that, the laboratory organizes creativity sessions. During a session, a group of participants generates new, original, and effective ideas to answer a problem raised. The session is organized in 3 main steps: the preparation, the ideation, and the implementation. Today, as you can see, creativity indicators are mainly at the beginning of the implementation step. If we want to assess our practices in creativity or assess the benefit of a new tool used during the session, we need to observe them. It's a question we will try to answer during this presentation: how to assess a creativity session during all the 3 steps. To do this, we develop a method of observing and analyzing our creativity sessions over the last 3 years. First, we stayed in the laboratory for half a year in total immersion doing participant observation. At the end of the 6 months, with the lab team, we defined 20 indicators to capitalize on our practices. Then we tested these indicators and made them evolve according to the new practices during the next 2 years. At the end of 2021, after testing and iterating during 43 sessions, we were able to highlight 48 indicators that allowed us to observe and analyze our creativity sessions over the 3 steps of its process. We have identified indicators for each step of the process. The first step is the preparation step, where we define the session scope, collect the data, develop the method and tools for the sessions. During this step, we have defined 17 indicators divided into 5 categories. At the beginning, we have the information specific to the organization. Which team requested the session, what is the project history, or what stage in the internal innovation process it is in. We capitalize after the problematic and the objective of the session, and the typology of the innovation, its nature, its degree, and its level. We also collect indicators for the tools and methods developed. For example, the number and the name of creativity and technical tools prepared, also if the lab developed new tool specifically for the session or not. The last category is the preparation time spent by the expert. And to collect all these indicators, we have 2 dedicated templates. After, during the ideation step, where we generated solution, we have defined 18 indicators divided into 4 categories. At the start, we assess the planning and organization. We mark the session format, the number of participants, the duration of the session, and the activities actually carried out. The second category is the group dynamic. Here, we observe the number of participants arriving late or not fully focused on the session and the number of participants intervening, asking questions, making remarks as well. We also observe the utilization of tools and methods, if the technical leader and creativity tools are consulted, if the participant requests the help, or if they handle the tools and mockup prepared. The last category is the session facilitation. We indicate the number of relaunch by the facilitator or modification of the time of an activity if there is an unforeseen event or if the technical leader is taking the role of facilitator. And to observe all these indicators, we have 2 observation grades. The last step is the implementation, where the experience is capitalized. To capitalize this step, we have 2 main categories of results to assess: the short-term results and the long-term results. Directly after the session, we collect the number of ideas generated, developed, and evaluated, if mockups are realized during the session or not, and if there is other traces. 1 month after the session, we do an interview with the technical leader to assess if patent or experimentation have been conducted. The last indicators we collected is the time spent by the expert team for this step. In order to validate these indicators, we have tested the entire methodology on 13 complete creativity sessions, from the preparation to the implementation. This session allowed us to validate our methodology for different profiles of session with different duration, number of participants, project typology, facilitation method, or even socio-economic context. But we also highlight limitation of the methodology. It's difficult to observe all the indicators during a hybrid or a remote session. We cannot observe correctly the group dynamic, the tool used by the participants, or the implication of each of them in the session. Even if it constitutes a first basis for sessions in hybrid mode or fully remote, it's clear that we must adapt to the indicators and methodology for these formats. Now, with this methodology, we will be able to assess the benefit of a new creativity tool implemented. Our objective is to create and implement a tool to support eco-innovation during creativity session and evaluate these advantages on our current practices. Thanks for your attention. Don't hesitate if you have any questions.
Hello everyone, I'm Niccolò Becattini from Politecnico di Milano. In the next few minutes you will see what we did to develop guidelines for the design of surprising products and test their usability. We chose to work on guidelines as the next step of this research that started several years ago due to the curiosity I shared with some colleagues studying design creativity topics. We started from the identification of product traits that are capable of eliciting surprise and proceeded towards the definition of the cognitive model that explains the general phenomenon of surprise emergence in the mind of an observer. This made it possible to set up an experiment that enabled the measurement of surprising traits and connect them to the cognitive processes that trigger surprise emergence. The identification of the product traits was mostly based on the three main variables of the function behavior structure framework. As products elicit surprise as an observer, the cognitive processes that make surprise emerge are strongly related to the previously conceived expectations in the mind of the observer. Surprise takes place when one or more of the three FBS variables interpreted from the external world do not match what the observer expects for the same. The proposed model of surprise emergence makes it possible to leverage product traits to challenge the expectations of the user, but the literature is still missing a prescriptive and procedural approach that enables the designers to develop surprising products on purpose. For this reason, we aimed at developing a set of guidelines that support designers in implementing surprising traits into an existing product, to make it more attractive, trigger curiosity, and give it a higher chance of market success. The guidelines are organized so that the designers need to choose which specific domain of the S framework they would like to work on to challenge the observer or user expectations. Then, the guidelines also support the identification of the product's essential traits and the sensory reactions which are typically expected, and ask the designer to think of opposite elements or radically different ones as a general strategy to challenge expectations. This is done through 8 paths: 3 to generate surprise via structural traits, 3 via behavioral traits, and 2 via functional traits. These paths have been organized into an interactive PowerPoint presentation that turns the prescriptive procedural method into a tool for improving its usability. One main window provides a message the designer needs to interact with to proceed with the step-by-step procedure of the guidelines. A navigation window to make the designer aware of the progress, and a bank of already generated ideas in case the guidelines are used iteratively. Here you see an example of how the tool appears with a blank form concerning the generation of ideas for the surprising behavior of the product. At the moment of the submission, the guidelines were just recently developed, and before testing their effectiveness, we needed to determine the usability of the tool. Poor usability of the same would have biased the evaluation of the effectiveness of the guidelines. More recently, we asked 150 evaluators to provide their opinion about the surprise generated by these concepts, which could also provide some initial evidence about the effectiveness of the guidelines. As said, we involved approximately 40 mechanical and industrial engineers to test the tool. 31 of them decided to participate in the experiment, which required them to use the tool to generate ideas. First, they need to use it with a product of their choice to become familiar with the tool. Then, to generate a bike with surprising traits. The figures on the right-hand side provide some examples of these ideas. Clockwise, from the top left, a bike to carry a wheelchair, a self-balancing bike, a mono-wheel bike that you ride from the inside, and a foldable bike that becomes a stool. The survey that involved 150 evaluators via prolific.com was structured avoiding the use of technical jargon and checked if the generated ideas were deemed surprising and for which of the traits we classify as function, behavior, or structure. A final question double-checks the coherence with the previous answers. The first step of the assessment made it possible to see that just 1 out of the 31 participants that carried out the experiment didn't manage to use the tool. All the remaining ones also found the procedure enjoyable. They were asked to use the tool, not to iterate its use. However, 6 of them iterated the use with the free product of choice, and 11 did it with the bike. This is a good outcome, as we expect that with the second product, they could be more tired and that they already spent too much time in the experiment. Through the second step of the experiment, we checked if the ideas the designer generated with the tool were also considered surprising by external observers. In general terms, there were no ideas that were surprising for everybody, confirming that surprise emergence is a phenomenon that concerns the individual, as everybody has their preconceived expectations. In general terms, however, 7 out of 10 concepts evaluated were deemed surprising by the majority of 150 evaluators. We also checked if the FPS traits perceived as surprising by the evaluators were coherent with the purpose of the path the designer followed with the tool to generate that product concept. We obtained a generally good alignment between the designer's intent and the FBS traits perceived as surprising by external evaluators. 3 out of 4 products evaluated show this alignment. In conclusion, we developed a set of 8 procedural and prescriptive design guidelines to generate ideas for surprising product concepts and embedded them into an interactive presentation that can be used as a tool. The experimental testing of the same showed that the tool is highly usable, and the preliminary check of generated product concepts confirms that these are capable of introducing traits that are generally considered surprising, also with a good alignment between user interpretation and designer's intention. The next step would be to check the effect that surprising ideas generated via the guidelines overperform the ones generated intuitively by a control group. Thank you so much for your attention.
My name's Laura Hay, and I'm going to present a piece of work that was conducted in conjunction with a master's student, Edward Hart, exploring the vividness of visual imagery in product design ideation. So visual mental imagery is the cognitive ability of generating, manipulating, and inspecting visual images entirely within the mind. It's believed to support the generation of ideas, and so it's conventionally been viewed as a really important component of design cognition. So there are a few different dimensions to an individual person's cognitive ability with visual imagery, but one of the most widely studied dimensions in psychology is the vividness with which people can generate and experience visual images in their mind. So vividness exists on a spectrum. Most people are somewhere in the middle. At the top end, we have something called hyperphantasia, which is visual imagery that is reported to be as vivid as real seeing. And then at the other end, there's a phenomenon called aphantasia, and this is the complete absence of any kind of visual imagery whatsoever. So hyperphantasia is believed to be more common in creative professions, but there have also been instances of aphantasia identified in some really quite successful creative professionals. And this is really interesting because it suggests that although visual imagery is really closely associated with people who are really creative, it seems that it is possible to be very successful in a creative capacity in a professional setting and have absolutely no visual imagery whatsoever. And it's this observation and this kind of curiosity that motivated the study I'm going to talk about in this video. So there is a widespread assumption that visual imagery is really important in product design, particularly in the ideation phase when we're generating ideas. And subsequently, there's an assumption that designers must be strong visualizers. But although there have been quite a lot of studies on imagery in design, there haven't really been any that have systematically explored the specific dimension of vividness and the role that that might play in product design. So we were interested in whether vividness varies across product designers in the same way that it does in the general population. And if it does vary, how does that affect the way that imagery is used by individual designers during design ideation tasks? We were also interested in whether there is a relationship between vividness and creativity in a product design context. And I personally am very intrigued by the question of whether there could be aphantasic designers and what that might mean for predominant visual reasoning models of design. So our approach, we took a sample of 16 product design students in the final year of an undergraduate degree. And there were 3 key elements to our data collection. So firstly, we asked the students to complete an open-ended product design ideation task. And we rated the creativity of the concepts they generated to give us creativity scores for each participant. We also asked the students to complete the Vividness of Visual Imagery questionnaire, which is an established psychometric test of vividness in imagery that's used in psychology, and that gave us a vividness score for each participant. And we also asked the students some questions about how to use visual mental imagery in product design ideation, and that gave us some qualitative data on the use of imagery in this context. And our analysis, firstly, we did some descriptive statistics to understand the variation in vividness across the sample. We then looked at Pearson's correlation to understand the relationship between vividness and creativity. And then we did some qualitative interpretation as well to explore the links between imagery use and the vividness with which imagery is experienced by students in our sample. So firstly, we found that there was variation in the vividness of visual imagery across the students in our sample. On average, our participants reported moderate to perfectly clear and vivid imagery. And just over 30% of our participants scored in the highest category on the vividness of visual imagery questionnaire, which indicates very vivid imagery and is possibly actually indicative of hyperphantasia. But just over 12% of our participants scored in the bottom second from bottom category on the questionnaire, which indicates very, very low vividness imagery. It doesn't quite indicate aphantasia, but it does indicate vividness that's considerably below average and below what you might expect to see in the general population. We also observed a significant strong relationship between vividness and creativity. So the students who reported more vivid imagery also produced concepts that were rated as more creative. And we did find that the majority of students reported that they did use imagery during product design ideation, at least sometimes. There was one participant who scored moderate vividness on the vividness of visual imagery questionnaire who reported that they never ever use imagery during product design ideation because they struggle to form mental images in their mind. And there were 3 others who reported some difficulties with forming mental images quickly. So there are lots of avenues for future research and observations discussed in the paper, but I just wanted to pick out a few key implications in this short video to talk about. So firstly, it's worth saying that we do need more studies with much bigger samples and more reliable and varied measures to be able to say anything in depth about what's happening with visual imagery vividness in product design. However, I do still think it's interesting that in our study, about 30% of the students in the sample reported that they are essentially not very vivid visualizers. And 2 of those reported only very vague and dim imagery. And I find that a bit surprising for students who are in the final year of a product design degree, when we have this assumption that all designers must be very vivid visualizers. So what could this mean? It could mean that maybe we should be providing formal imagery training as part of design education. But I think a more interesting question is whether this suggests there are alternative ways of imagining in design that are not captured by the predominant visual reasoning models we currently have. So aphantasics in psychology have been found to employ a whole range of alternative strategies when you ask them to do visual tasks. And these include different modes of imagery, avisual spatial imagery, kinesthetic imagery. And I wonder whether current models of designing neglect other modalities of imagery, so tactile imagery, kinesthetic imagery, auditory imagery that might be important in design. And even if designers who don't rely on visual imagery during design tasks, even if they are outliers, what could we learn from studying these designers that might tell us something interesting about design that may be useful for other designers and may help to extend our current models and theories about how design works from a mental imagery perspective? So if you want to know more, please read the paper. There's a lot more detail in there, and please feel free to get in touch with me as well, and I'd be happy to chat with you about the work.
So before the next video starts, I'd just like to suggest Laura to use some vivid mental imagery to imagine us handing her a glorious trophy to celebrate that this is a reviewer's favorite paper. And certainly if you are new to the field and want to take a paper as a good example of doing these kind of experimental works, this is a nice paper to have a look at as a starting point. So nice work, Laura. Congratulations. And now on to the next video.
I'm very pleased to be with you today to talk about the relation between the characteristics of individual and collaborative concept generation. Here is the outline of my presentation. Here, I'd like to start by talking about why we focus on this topic. In the process of design, and especially during concept generation, designers often became aware of the self that is working in the background, and in doing so, gain a strong sense of expanding perspective. Most also noticed that the nature of collaboration differs depending on who the collaborators are. So we decided to investigate the effect of the concept generation process on metacognition and the relation between the individual concept generation characteristics and the nature of collaboration. In the next slide, I'll introduce some related study. Many previous studies have reported that suddenly appearing ideas called creative leaps have led to excellent design solutions. Creative leaps are understood as phenomena enabled by an acquired metacognition, either from relaxation of constraints or release from fixation metacognition. Following this, we examine the characteristics of each examinee from the perspective of metacognition. Creativity in collaboration has been confirmed to imply an integrative approach according to which individual creative skills, team dynamics, and organizational solutions interact, and an appropriate organizational strategy is more effective, especially for novice designers. So, secondly, we elucidate the influence of individual concept generation characteristic on collaborative concept generation. In this section, I will introduce the research methodology. We compared the individual's concept generation characteristics with the nature of collaboration observed in the experiment to understand the relationship between them. We understood and compared the concept generation with the metacognition observed in the experiment from each concept and each generation process to understand the relationship between them. The experiment was conducted with the examinees, and the experimental procedure shown on this slide. The examinees generated concepts using multiple words as the task. Immediately after each concept generation, the examinee individually reviewed their work with recorded materials. In this section, I will introduce evaluation methods. We focused on two perspectives, so as shown on this slide, we established the criteria for metacognition evaluation. We evaluated metacognition by supplementarily analyzing the inner thinking process of the examinee through the examinee's written reflections. And then we classified the results by 4 types as shown in this slide, with the relaxation of constraints and the freedom from fixation established as axis. Each examinee's metacognitive transition process throughout the individual concept generation exercise was categorized by the following the perspective of basic metacognition state and stability, focusing on the relaxation of constraints. Based on the previous study by Matsumae and Nagai, in this study, co-creative collaboration is defined as a collaboration in which individuals share tacit knowledge and create something together. Therefore, co-creative collaboration in this study was determined when both of these were observed. In this section, I will introduce this study's results and discussion. This graph shows the results of comparing the concept generation methods for each metacognitive transition patterns. Only the top 2, which are fundamentally constrained and relaxed, generated concepts not only by the free association method but also by other various methods. This graph shows the results of comparing changes in the quality of the generated concepts for each metacognitive transition pattern. The examinees on the right end were considered excluded because they were clearly unmotivated. We focused on the high originality average and the low originality average, the metacognitive transition pattern in which the more stably the relaxation of constraints occurred, the wider the range of the originality. This slide shows the discussion from these results. Some people have the attitude that there is a limit to one's own field of vision and perspective. Those who have this attitude give themselves the opportunity to notice and overcome these limitations by actively adapting various concept generation methods, and thus acquire metacognition in the process of concept generation that results in a metacognitive transition pattern with relaxation of constraints. As a result, the range of originality of the concept generated widens, and highly original concepts can be generated. This picture shows the result showing the relationship between the pair type and the co-creative collaboration ratio. When the concept generation characteristics of the individuals, which were gleaned from the concept generation work, were compared with each pair, 3 types were revealed. For each concept generation in the pair concept generations, we calculated the ratio of co-creative collaboration to the total. Next, we ascertained how they recognized the subject of the pair concept generation. It was observed from the reflections that the pairs who were not conscious of being a pair at first gradually became conscious of being a pair when one of them showed interest in and sympathy for the other. In conclusion, it had been observed that the direction of the individual context vectors of the concept generation process, the degree of freedom, and the degree of the intersubjectivity formation are fundamental factors that determine the nature of collaboration. The relationship between these factors is detailed in this figure. If one brings the tip of their own context vector closer to the tip of the other context vector, the other context vector will gradually come closer as well, making it easier to share and generate tacit knowledge. The knowledge obtained in this study contributes to the optimization of creative team formation, but the study's experiment was based on words. Therefore, the individual difference among examinees may need to be considered in another context. These are the references. Thank you for your attention. Do you have any question?
Hello and welcome to a presentation about a new biomimetic approach. I'm Marcel Bartz from the Institute for Engineering Design at the FAU Erlangen-Nuremberg. Biomimetic is commonly referred to learning from nature through the stages from the discovery of a biological solution to the technical application. Basically, in biomimetic, a separation is made between the bottom-up and the top-down approach. In the bottom-up approach, a solution is observed in nature, and a suitable problem has to be found in technology that can profit from this solution, also called biology push. An example would be the great burdock, a plant whose fruits have microscopic hooks, whose working principle led to the invention of the Velcro fastener. Within the top-down approach, it's the other way around. There's a problem in technology, and for this problem, solutions in nature has to be searched for. This is called technology pull. An example would be self-sharpening tools or knives. Suitable solutions to minimize wear could be found in nature by the tooth structure of rodents, where one side wears faster than the other side, so that a sharp cutting edge always remains. There are several successful examples of biomimetic products that have made it into the market, but however, there is an imbalance between biomimetic research and real implementation in technology, especially in the bottom-up approach, where the need from industry has yet to be found. As an example for this, I've included a quote from a recent journal article that refers to a paper by Jacobs et al. From 2014, where it mentioned that their 86 commercial available products met the criteria for being considered as biomimetics. The reason why there are only a few biomimetic developed commercial products available so far are complex. The biomimetic development process in the bottom-up approach starts in the field of academic research, mostly by public funding. Thereby, the focus lies on the discovery and of the biological solution and the following fundamental research. In industrial application, usually takes place through private investment. Thereby, the focus lies on the development of the technical product and its commercialization. However, between academic research and the step into industrial lies an area of technology transfer in which a collaboration between academic research and industrial companies must be found. This often fails because applied research is lacking, since the focus in the academic research phase was on fundamental research. This gap is also referred as a valley of death in literature. And this is precisely where a new approach comes in which we assume that for some applications, it can be advantageous to switch relatively quickly from the fundamental research to applied research, and to collect experience directly in industrial above the cause-effect relationships. In the new approach, the process of gaining knowledge in a biomimetic process is iteratively in the biomimetic spiral shown here. The fact that biomimetic works iterative rather than linear is not necessarily new, but the biomimetic community has been discussing for a long time how exactly biomimetic development takes place within the product development process. Therefore, this spiral shown here has been integrated in an extended form into the new guideline for biomimetic design methodology of the Association of German Engineers, which will be published in June this year. In contrast to the classical biomimetic in which the gain of knowledge takes place on the biological side, the new approach starts with a quick run on the biological side and then goes through all further iteration loops directly on the technical sides, so that the gain of knowledge directly takes place on the technical side, here referred with T1 and T2 and so on. Starting from a biological side, the biology technology barrier is crossed directly after one passage of the biomimetic spiral, resulting in the first technical solution T1. The passage through the biomimetic spiral is continuous, and with all further technical solutions T2, T3, and so on, the gain of knowledge continues to grow. However, directly on a technical level, at some point, the academic industrial barrier can be overcome and a collaboration with the industry can be established. Now, how can we directly overcome the biology technology barrier without first having a full understanding of the principles of actions on the biological level? Instead of investigating the causes in biology in order to produce a desired effect in technology, we try to achieve the desired effect directly in technology using inverse methods. This will be explained on the next slide using the musculoskeletal lightweight design as an example. In brief, the lightweight design of musculoskeletal system is based on a complex interplay of several principles, mainly the structural adaptation of bones to the mechanical stresses and the redundant motion generation with the tension cording of the muscles to avoid bending stresses. The interaction of these principles leads to the observable effect that the human skeletons consist of very minimized lightweight structure, so that there is a clear causal relationship between causes and effect. If we now want to use biological lightweight design due to a biomimetic process, we should first have to understand the interplay of these causes of the lightweight design detail. However, it's difficult due to several factors, including the fact that muscle forces cannot be measured exactly and the microbiological processes involved are very, very complex. However, it's not possible to conclude the causes from the observed effect because there is no causal relationship here. So the idea is now directly to cross the biology technology barrier and then achieve their bending minimized lightweight design structure directly in technology as a desired effect, and then to use multi-criterial optimization methods, in particular inverse methods, to find technical causes that achieve the desired effect in technology. For a detailed description of these last steps, including the optimization methods, please refer to the paper linked here. Here, the application of the new approach is shown by actual results of our own work on the transfer of the lightweight design potential shown before to technical applications. In the first phase of work, Research Project 1.1, we first carried out studies on the biological lightweight design on the biological level within the framework of the biomimetic spiral. Then we directly crossed the biology technology barrier and developed a first virtual demonstrator and collected further knowledge using it on a technical level. Within this knowledge, we went once again through the biomimetic spiral and developed a second demonstrator according to the latest results from the Research Project 1.2. And currently, we are working on a more specific implementation level so that industrial implementation can soon be carried out and the academic industry barrier will be soon crossed. In summary, I would like to add that this new approach is not a hypothesis that an exact biological investigation should no longer be carried out as part of a biomimetic process. Rather, it is intended to be an additional tool for biological systems where the analysis of cause-effect relationship is difficult or impossible. However, it is important not to make things too easy for oneself, because the lack of understanding of the biological mechanisms of action could lead to a loss of potential for technology. But for technical hands-on engineers, the presented approach could be a support to make the application of biomimetic methods easier. Therefore, a proof of concept of the new approach must first be evaluated and validated for other biological systems. As mentioned, part of our work have been included in the new VDI guideline. You can find it here together with the journal paper about the development of the guideline. Yeah, thank you for your attention. Feel free to get in touch with me for further questions and comments. Thanks and goodbye.
Well, thank you very much to all the video presenters. there was some really nicely done videos. That was quite good, and I'm sure everyone is now looking forward to being able to speak after so long watching videos. So it would be good to start off with some questions to the specific presenters, and then I think we can go from there. Does anyone have any questions for video number 1, how to assess a creativity session? There wasn't any in the chat other than my own. Okay, so then we will go to Niccolò, and then we will come back to cross-cutting questions. So for Niccolò, there were some questions from Lili and Laura and also Yuri. Oh no, about surprise and novelty and whether surprise is a desirable thing.
Well, so surprise relate to novelty. I mean, in the literature, you can find different points of view on the topic, but I would say that surprise, if we think about surprise from the perspective of the observer, so the guy that perceives surprise as a reaction, as an emotion, it's something that definitely has something to deal with novelty. But I would say it's P novelty. So it's personal novelty and it's not historical novelty. So something which is new to the observer can trigger some surprise. Why am I saying this? Since if you already get to know something, probably you reset your expectations and you are probably not so surprised the next time you see it. So surprise, it's also a volatile phenomenon. It happens once, it hardly happens twice, with the same thing, obviously. So I don't know if I answered to your question, Laura. Then someone is ringing to my door. This is what happens when we are doing the things remotely. Sorry for this. Then, how can I consider a product is surprising or not? Actually, it's not me, Lili, who is considering if a product is surprising or not. Obviously, surprising, as I said, as it depends on P novelty. So personal novelty obviously depends on the eyes of the observers. So that's why we wanted to check the outcomes of those preliminary testing with the guidelines. And I agree with the comment that it's hard to distinguish at the moment what's the impact of the tool and what's the impact of the guidelines. But in general terms, I'd say that you need to ask someone else. So some products are surprising to a large majority of people. Some other products are not. Are they surprising for everybody? Obviously not. So what is surprising for me, maybe it's not surprising for you. It's a matter of how we set our own expectations, and everybody has its own. If we need to design surprising products, what we can do is to make some hypotheses about what are the expectations of the users, of the observer, and try to deviate from that. And most of the literature refers to sensory incongruity, which is what Gekeluden did in the past, and what Mary Lou Maher, on the other hand, tried to mention in terms of the deviation from a standard trajectory for the evolution of a product. So whatever goes beyond that, or in a different way, it could be surprising. We cannot be sure that it's surprising. That's the point. So is it a desirable property? Well, we can see that the same product can trigger a positive or a negative surprise to someone. Typically, the more it sounds novel to the eyes of the observer, and the more it can be astonished in a positive and in a negative way. So if we don't have anything which is too new to the eyes of the observer, but sufficiently to deviate from a certain trajectory, that surprise can trigger a positive reaction, so create stronger affection, more interest, attention, and so on and so forth. But actually, I need to say that I don't have any concrete evidence to say this. This is much more a perception concerning what we observed in previous tests, but we did nothing tailored to measure this element.
So it does sort of connect to the work on like perception and acceptability. Yeah. Lili, how does that connect to your paper where you're talking about the indicators? because obviously this, I guess, would be some sort of indicator in the range of like quality of ideas or diversity of ideas, or
Yes, it's connected to the paper because we also evaluated the creativity session. We not evaluated the ID at the end of the session, so we don't evaluate it if it's now we don't evaluate it if it's novel or not. So that's why I asked the question, because we work on how evaluated if an ID is an eco ID, if I can say it's in an eco-innovative ID. So that's why I asked the question, because today we don't really know how we can evaluate the novelty or the eco ID, except thanks to the thing of the participant and of the people who evaluated, but we don't have a real criteria on it.
okay, that's good select point. Okay, there's quite some questions for Laura from Yuri, Niccolò, Samuela, and Chris. So the first was to do with vividness and fixation, and then how we might train vividness of imagination. Do you have any plans for doing neurocognitive testing? Probably you do. And then how linked to the design action or design approach used? So just a simple matter of answering, how does it exist in any kind of design context in all that complexity?
Sure. Okay, I'll try my best to answer. So, Yuri, your question first about vividness. I think this is a really interesting question, something I didn't cover in the video. When we did the kind of qualitative questionnaire on how the participants used imagery in the design process and the reasons why they didn't use imagery, some of them actually said that they sometimes try to avoid visualizing things, to avoid it kind of having one image that overwhelms their whole mind and blocks creativity. And when I saw that, I instantly was like, oh, that might be connected to fixation. So I think for sure it's possible there is a connection between maybe the higher your vividness is, the more likely you are to fixate on the early ideas you come up with in the design process. I have no idea if that's correct or not, but it's something I would like to look into in more detail. Are we planning neurocognition studies? I would obviously love to do that. There's been quite a lot of work on neuroimaging work on imagery in cognitive neuroscience, trying to map out the brain regions involved. There was quite an interesting study recently that identified neural correlates of these two phenomena I was talking about. So hyperphantasia, really vivid imagery, and aphantasia, the complete absence of imagery, which is interesting because a big criticism of all of the research on mental imagery is that it's completely subjective. There's no objective measure you can really use to determine how vivid someone's imagery is. It's all just self-report. So yeah, I would really like to do some neuroimaging stuff, but I think it requires careful planning and careful study design and thinking about what meaningful research questions we could answer with neuroimaging that couldn't maybe just be answered with cognitive studies, and what we could really learn about imagery in design specifically that isn't just kind of regurgitating all of the neuroimaging stuff that's already been done on imagery in neuroscience. So I would love to do it, and I'm definitely thinking about it, but I don't have a concrete plan in place at the moment. The other questions, yeah, the question about education. So yeah, this is something that I also discuss in the paper in a bit more detail. So there has been some work that has shown that you can train imagery. There's actually a huge body of literature on the use of imagery in sport to train people to be better at sport and skills involved in different sports using imagery. But there has also been a few studies that have looked at whether you can increase vividness of imagery through training exercises. They've been a bit inconclusive so far. So I'm not sure. I think it is a possibility. And something I talked about in the paper is whether we could develop some kind of pedagogical approach in design education that would help people to crystallize the images that they form in their mind in the same way that we spend a lot of time teaching people how to externally represent and visualize their ideas in sketching. Something that I am kind of curious about is there has been some research using brain stimulation to see whether you can increase the vividness of someone's imagery, which is a little bit more invasive than just training someone, actually sticking electrodes on their head and zapping their brain. But there's been some kind of interesting results to come out of that. It seems that you can't, if someone reports a complete absence of visual imagery, you can't make them have visual imagery by stimulating the brain. But if they have some visual imagery, it seems that you might be able to increase the vividness of those images using brain stimulation. So I'm quite interested in that side of things as well. I can't remember what the last question was.
It was to do with how was it linked to the design approach adopted by the person, from Chris Cox, if you want to.
Ah, okay, yeah. Yeah, so we didn't actually ask the participants who tended towards aphantasia. We didn't actually ask them how they went about the design task, which I would really like to know. And again, that's an avenue for future work that I talk about in more detail in the paper. There has been, as I mentioned briefly in the video, quite a lot of work on aphantasia in psychology. It's a relatively newly identified phenomenon, but there has been some work looking at how aphantasics approach tasks that we would conventionally consider to be quite visual predominant. And they definitely seem to adopt alternative strategies. And I don't know whether we would see similarities in designers who rely less on visual imagery. I really don't know what the answer to that is, but I'm really, really curious. And something I would really like to do is to dig into that in more detail, to study some of these designers who, as I said in the presentation, they might be outliers. It seems like most designers use visual imagery in some capacity, but the ones who don't, I'm so curious about how they approach designing. As someone who has I feel like I have quite a vivid imagery myself, I can't comprehend how someone thinks about designing without visualizing stuff. So personally, I'm extremely intrigued by that question, and I would like to do some more studies in that area.
Well, any other questions for Laura at this time? I think we have an opportunity to come back to everyone. Okay, so we come on to Hikari, and Sonia had a question for you in the chat. So about basically how does it metacognitive awareness relate to fixation, flexibility, and creativity? Is Hikari here?
She said in the chat that she is waiting for the approval for getting back in.
Hikari, can you please refresh your page and try again?
Okay. In the meantime, then we will go to Marcel.
Yeah. Okay.
So we had a question from Niccolò in this case. To do with what really differentiates this method as opposed to any number of others, I guess.
I wrote the questions on the extra documents and I answered them, so I can see them. And Niccolò, you asked what I mean, or we mean, with biological function, or is it different to a technical function? No, it's the same, because in biology or biomimetics, the process is you find a solution, then you abstract it, and everything you do on abstraction level. It's the same abstraction level you do in technique. So it's the same functional view on the system. And then you go back on the technical level, and then you can, it's the same. Okay, Philip, you had two questions I saw in the chat.
I would take the
other one first.
The crowd questions.
Yeah.
I'll just drown everyone.
Yeah. Okay. So Niccolò, you had another question. If we can point out the main difference between this approach and the approach from Chakrabarti, Uno BID by Cassini. I don't know their approach in detail. Perhaps my co-worker Eike Uttich, who is also here, knows it, but we came more from a technical point of view. We had a main focus on lightweight design, biomechatronics, and the focus was more on using inverse methods to reverse the cause-effect relationships. So we don't come more from the other side. So I don't know what in this paper is written. Perhaps you know it more, or you can look into our paper, and then you can write me an email and ask the question again. So yeah, that's all I can say to this question. Sorry.
Seems like a pretty critical one to think about answering.
Yeah, I've got something to read for my homework. Yeah, I think these were the questions.
Yeah.
Except the one you had.
Well, it would be great if Hikari can join. Hikari, are you there?
Yes, I'm here.
Awesome. So, yeah, Sonia had a question to you. Do you want to offer an answer to that? It was to do with how does metacognitive awareness relate to fixation, flexibility, creativity, and so on.
Sorry, one more time, please. Sorry.
It's written in the chat by Sonia Vieira. So it says, very interesting study. Can metacognitive unawareness lead to fixation in ideation? And does metacognitive awareness confer flexibility to design creativity?
Okay, thank you so much. Thank you for asking, and I'm sorry for waiting you. And actually, I don't catch the awareness of the unawareness point. So yes, it's my answer.
Okay. So, Sonia, do you have any response to that? Okay. Do any of the authors want to ask questions? Because I guess you're busy thinking about your own presentations and then the questions coming to them. Does anyone have any questions for anyone else?
Sorry, I let the chat question, and I think before having a travel, I think travel. I let the meanings of my studies. Some asked me about my course, I think. So I want to answer this question, and can I answer you? No?
Yeah, if you like.
Okay, thank you. So I think my studies meaning is not everyone in the teams need to be co-creative and don't have the co-creative collaboration attitude, but the one co-creative person can enhance everyone's creativity in a team. So this is the knowledge of in our study is the contribute to the optimization of creative team formation. I think.
I think it might be a good idea for you and Sonia to find time to have a chat, because it seems like Sonia has quite some questions that need a bit more discussion for you. So I apologize, Laura, but I have a question for literally everyone except you. And it's something that I have only just been thinking about recently, and it's, is anyone thinking about the potential side effects of the tools and methods that you're proposing? Because obviously with any kind of assessment metric or assessment sheet, you invite people to game that kind of assessment. With any creativity tool, there's potential side effects in all different dimensions. And with the biomimicry stuff, you definitely have some kind of constraining lens that you're putting on yourself, and could even come into conflict with organizational culture and things like that.
For biomedics, it's the work we've done is in the field of a guideline in Germany we developed, where a lot of researchers from Europe are in, and also many engineers from industry. So the topic or the scope we were aiming was directly the industry to help them. It was not only an academic thinking, that would be a nice theory. That's the field where we put our scope to. So we are directly on getting that they use these methods in industry, not only in academics.
I think that wasn't quite what I was asking.
Okay.
Just in the sense of when you introduce something, you're bringing
you're
bringing a prescription and prediction.
Mm-hmm.
And obviously, when you put things into a system, it can have unexpected outcomes or negative side effects.
Yeah. Okay.
Have you given any thought to that?
No, we came from the other round because we saw negative side effects from the state of research right now. Because in industry, people try to use biomedics and they get negative outputs. So we wanted to avoid that they get negative outputs. So we came from the other side. There was a need in industry to avoid the negative outcomes from the stuff which they get from the research.
Okay, perhaps it would be good to hear from Niccolò and perhaps Lili
let's
as well.
say that we're proposing guidelines that are structured within a tool, and by definition, if we are prescribing something to someone, we are somehow constraining his way of thinking. So, in one way, I'm afraid that this could lead to potential fixation effects, despite we leave the user of the guidelines relatively free to explore, and we try to boost the exploration by triggering some thoughts that go beyond the standard way of thinking. But at the same time, I'm afraid that we can't be 100% sure that this would be the good strategy to achieve what we want. So that's why we wanted to first test the usability of this tool. And then it would be nice to test the guidelines as they are. In any case, as they are written down on paper, they are a tool in a way, because the way they are presented, it's a tool. At the same time, the interactive presentation does the same, so we can try to compare what's the impact of the tool in that case to deliver some expected results. So still talking about expectations, and we can also see if the absence of guidelines, so the free way of thinking for engineering designers, industrial designers, lead to more surprising outcomes than the guidelines. So it means that we didn't do a good job in the end, but it's something that we need to test.
Lili, do you want to comment?
Yes, in our side, so we have already introduced these methods in our practices in the industry, and we have co-created with the industry, so there is no real negative side to introduce it, but one of the limitations is limit between the observation and the evaluation. So now we observe a group dynamic, so we observe people during creativity session, and we have a lot of feedbacks around the difference between observation and evaluation. When we observe some session, we have people who come at the end and say, did we have made a good choice, or did we have doing great? But it's not really the objective of this methodology. So it's one of the negative aspects, and one of the limitation. It's the difference between the observation and the evaluation, and it's difficult to explain that to people because it's always in the industry. It's a little difficult.
Thanks. So, Lili, your tool deals with essentially collaborative idea generation or group contexts, correct?
So the methodology is complete just by one person, an observer, but it's the objective is to observe, yes, a group, a creativity session in group. So it's a collaborative session. It's how to evaluate or how to observe what we call the workshop. So a creativity session in group.
So how do you think, so I'd like to ask you and Hikari, how do you think your two bits of like research streams would interact? Because obviously Lili, you're providing a framework for observing it and like scaffolding reflection to some degree. And Hikari is talking about the individual characteristics of collaborative creativity. So there's some interaction there between what you're prompting people to think about and develop, right?
Sorry that I couldn't catch the meaning. So what is the question? Sorry.
I was inviting you to comment on each other's work, basically. I think it would be interesting to hear from Lili what her thoughts are on your insights about group creativity. Oh, okay, she's gone. Never mind. Do you have any thoughts on how it might interact with things like group creativity, Lili?
I don't really know. I think this work is more deeply maybe than mine, because mine it's really in a macro level, so we don't really evaluate or we don't observe what it's say between interaction. We don't we just observe the interaction. So if there is interaction, but no the content of that.
Yeah, okay. Does anyone else have any questions? We've got like 5 minutes left. Okay, you guys putting me on the spot. But,
maybe I have one to Laura. Since I don't know how much it deals with vividness, but there is a phenomenon which is pareidolia. I don't know if I'm pronouncing that properly, but it's, let me try to, I mean, you get the point, which is a way of making some meaning out of an image that doesn't have that meaning. And I think that somehow there are connection points with vividness. Did you check anything about this and the fact, since I think that this could be a good proxy to find analogies through visual imagery?
Yeah, we didn't look at that, but I think it also, I guess it connects to, yes, so pareidolia is the seeing faces specifically, I think, in
not necessarily
objects,
faces, but recognizing figures that
yeah.
are not, so something that you can see maybe in clouds. Or,
yeah, exactly, like seeing an animal of some kind in the clouds, yeah. We didn't look at that, but I think it could be connected because there's a lot of literature in design cognition on the idea that like when you're sketching, you are constantly reinterpreting the visual image on the page in front of you, and that kind of drives this evolution in your internal visual image. So there's this kind of interplay between your mental imagery and the images that you see on the page in front of you. So I think there definitely is a connection there. It's not something that we really explored, and actually part of my motivation for doing this study was the fact that seems to be kind of this accepted thing in the design cognition literature, that's how it works. You interpret your sketches and make some meaning out of them, and that evolves your mental imagery and so forth. That's how the process moves on. But then I started reading all of this literature on like animators and artists and people who take a completely different approach, and they don't seem to have that connection between what they're visualizing on the page and what's going on inside their head. So I think there is a connection, but maybe it doesn't exist in everyone. I don't know, but for sure it would be interesting to explore that further. And I hadn't really connected it to pareidolia. I don't know how to pronounce it either. It's something like that. But that's an interesting idea.
Thanks.
Does anyone want to share any final comments, particularly from the presenters? Okay. Well, in that case, I would just like to thank all presenters for doing a good job with their videos and also answering the questions and keeping this conversation alive, which is good. I think there's some quite interesting cross-cutting themes about the testing of design methods and design tools, and certainly how things like visualization and collaboration can be still further theorized in design research, despite the fact that there's so much research in that topic area already. So there's really good potential for quite a lot of this work to go forward and make an impact. And it would be really exciting to see some of these papers further down the line as research articles in journal outlets. So good luck, everyone. Thank you very much for presenting. And yeah, I guess we can give a round of applause for videos. You know.
Thanks a lot, Phil.
Yeah, thank you for sharing.
Thank you,
Philip.
thank you, Phil. It's
pleasure.
never easy.
Thank you.
Okay, well, good luck and see you at the next session.
See you.
Bye.
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 Bye-bye.
Bye.